Bismillahirrahmanirrahim. How are you students? I hope you are fine. Well, this is going to be the second lecture on the series of online classes for the students of class 7, and in this lecture I am going to cover factors of algebraic expressions and its applications. And by its applications I mean I am going to use factors of algebraic expressions to determine highest common factors and least common multiples of algebraic expressions. Factors of algebraic expressions are very important while you try to find solutions of equations. So in this lesson, I have prepared it for you to understand factors and different techniques of finding factors. And when you are done with finding factors, you will be able to use it for finding the highest common factors and least common multiples of algebraic expressions. A number can be found by multiplying by its factors. For example, factors of 12 are 1, 2, 3, 4, 6 and 12 itself. Now, you can get 12 by multiplying by its factors, like 6 times 2 equals to 12. That is, any number can be expressed in the form of its factors as explained above. In a similar manner, algebraic expressions can also be found by its factors. From the next slides, I will try to show some different ways of factoring algebraic expressions. Factorization algebraic expressions is similar to finding factors of real numbers. The only difference is that we use identities and many other methods instead of just prime numbers. Algebraic expressions can be factorized by many methods. Some of the most popular methods are as follows: factorization using common factors, factorization by regrouping terms, factorization using identities. Well, there are many other methods, but we will be focused on these methods only. So let us see the first method, and it is factorization by common factors. In this method, we first try to find the common factors as the name suggests, and then we will take out the common factor from the expression to resolve the expression into factors. Let us explain this through an example. And the example is factor 2y plus 6. You can see that 6 can be written as 3 times 2. And by writing 6 as 3 times 2, we see that 2 is the common factor here. So we have taken out 2 to factorize this expression. Now let's try to understand the second method of factorization, and it is factorization by regrouping terms. And we use this method other than common factors as it is not always possible to have common factors of every term. Now consider the problem 12x plus y minus xy minus 12. You can see we have 4 terms and not every term has a common factor, but the first and last term and the second and third term seems to have common factors. So the terms that have common factors, we have grouped them together and then we have taken out what is common in between them. You can see in the first and the fourth term 12 is a common factor, and the second and third term y is the common factor. So we have taken out 12 and y from those expressions. Now in this expression, in the second term, we can see that if we take out the minus from y times 1 minus x, then it will be like 12 times x minus 1 minus y times x minus 1, and again x minus 1 is the common factor here, so we have taken out x minus 1 to resolve this into factors. Thus, by regrouping terms, we can factorize algebraic expressions. Now you can see the regrouping is a very useful tool while you are factorizing. Now I am going to illustrate to you the most important method of factorization, and it is factorization using identities. And to understand this method, we first need to understand what is an identity. Well, an identity is an equality relation which holds true for all the values of variables in mathematics. Okay? Now here are some popular identities like a squared minus b squared equals a plus b times a minus b, a plus b whole squared equals a squared plus twice ab plus b squared. There are other identities like x plus a times x plus b equals x squared plus a plus b times x plus ab. and x minus b equals x squared minus a minus b, a plus b times x plus ab. Well, there are many other identities. We will be focused on these identities for this lecture. Now I am going to use one of those popular identities to factorize a rather complicated problem. Now, by looking at this problem, you might be wondering what to do, but don't worry, as we have the identities. Okay, first look at the problem carefully. Do you find any matching identity? Well, if you don't find any matching identity, let me help you. Look at the first term and the last term carefully. The first term is 9x to the power 4. That means it is 3x squared whole squared. That means it is a perfect square, and so does the last term 4 or 2 squared. That means the problem fits into the identity a squared plus twice ab plus b squared, as the first and the last terms are perfect square. Now let us solve this problem. As you can see, 9x to the power 4 is written as 3x square whole squared plus 2 times 3x square plus times 2 plus 2 square, and in the middle term you see that 2 times 3 times 2 is 12, but we had 8x square, so we have subtracted minus 4x square. As the first three terms can be expressed as a plus b whole squared, we have written it 3x square plus 2 whole squared and minus 4x squared. Now again it fits into another identity of a squared minus b squared. So we have done this 3x squared plus 2 plus 2x, 3x squared plus 2 minus 2x. Now you can see we can use identities to solve to factorize many complicated problems. In this slide I am going to use this identity with a simple example. X square minus 15x plus 56, and we must factor this expression. As you can see, 15 can be expressed as 7 plus 8 and 56 as 7 times 8. Well, this fits into the identity x square minus a plus b times x plus ab. So this expression equals x minus a, x minus b, or x minus 8, x minus 7. Okay? Now you have a homework. Factor this expression 16x to the power 4 minus 81y to the power 4. Now you will see how you can use your knowledge of factorization to finding the highest common factor, or H.C.F. of algebraic expressions. First you need to know what is the H.C.F. of algebraic expressions. The product of the highest number of factors which are common to two or more quantities is called the highest common factor. Well, there are many methods of finding the highest common factors, but I am going to show you a method that in there you can use factorization, and the steps of finding H.C.F. in these methods are: finding the H.C.F. of numerical coefficients, resolve the algebraic expressions into prime factors, product the H.C.F. of the numerical coefficients and the successive multiplication of the prime common factors of the algebraic expression. Then you are done. Okay? Now let us find the H.C.F. of 2a square minus 8b square and 4a square plus 4ab minus 24b square by factorization. Here the first expression is 2a square minus 8b square. We can see that 2 is the common factor here, so we have taken out 2, and it takes you to 2 times a square minus 4b square. Now you can see that a square minus 4b square, it actually fits into another identity of a squared minus b squared. So a squared minus b squared, that means a plus 2b and a minus 2b. So the first expression is reduced to 2 times a plus b times a minus 2b. Now let us see the second expression, and it is 4a squared plus 4ab minus 24b squared. You can see that 4 is a common factor here, so we have taken out 4. So it is 4 times a squared plus ab minus 6b squared. Now the midterm ab can be split into 3ab minus 2ab, because 3ab minus 2ab is ab minus 6b squared, and in the first two terms a squared and 3ab, A is common, so we have taken a plus 3b, and in the last two terms 2b is common, so we have taken out minus 2b, then it is a plus 3b. And in this expression a plus 3b is common, so we have taken out a plus 3b, and then it is a minus 2b. So finally the second expression is 4, or 4 is 2 times 2 times a plus 3b times a minus 2b. Okay, now in the first expression and in the last expression, we can see that 2 is a common factor and a plus 2b is not, because in the second expression we do not have a plus 2b, but we do have a minus 2b in both the expressions. So a minus 2b and 2 are common factors of these two expressions. Hence, the HCF is 2 times a minus 2b. Now let us see another example. Find the HCF of x squared plus 7x plus 12 and x squared plus 9x plus 20. Here the first expression is x squared plus 7x plus 12. Now you can see 7 can be expressed as 4 plus 3, and 12 can be expressed as 4 times 3. So you can see that this fits into the identity of x plus a times x plus b. So it can be written as x plus 3 times x plus 4. Now let us see the second expression. It is x squared plus 9x plus 20, and you can see 9 can be expressed as 5 plus 4 and 20 can be expressed as 5 times 4. So you can you see that this expression also fits into the form x plus a x plus b. So it is x plus 5 x plus 4. And from the first and second expression, we see that x plus 3 and x plus 5, they are not common to both the expressions, but x plus 4 is common for both the expressions. So our HCF will be x plus 4, as x plus 4 is the common factor. Now let us see how you can use our idea of factorization to determine LCMs, or least common multiples. First we need to know what is an LCM. The product of the highest power of all possible factors. Well, I did not mention all common factors, rather I mentioned all possible factors of 2 or more expressions is called the least common multiple. Well, there are many methods of finding LCMs, but we will be focused on finding LCMs by factorization, and there are many steps of finding LCMs from these steps. Here are the common steps. Finding the LCM of numerical coefficients, and then you need to resolve the algebraic expression into factors and product the LCM of the numerical coefficients and the successive multiplication of the highest power of all possible factors of the algebraic expression. Now in the next slide we will see how we can find the LCM by an example. And the example is find the LCM of x cubed plus 2x squared and x cubed plus 3x squared plus 2x by factorization. Here the first term is x cubed plus 2x squared. You can see x squared is common, so we have taken out x squared to resolve it into factor, and it is x squared times x plus 2. And the second expression is x cubed plus 3x squared plus 2x. You can see x is common, so we have taken out x to get x squared plus 3x plus 2. Now the midterm is split into 2x plus x, that means 2x plus x is 3x, and we have taken out x from the first two terms, and it takes you to x plus 2, and 1 from the second two terms plus 1, that is x plus 2. And by taking common x plus 2, we got x times x plus 2 times x plus 1. So from the first and second expression, we see that the highest power of the included factors of the given expressions are x squared, x plus 2 and x plus 1. You see that x plus 1 is not common in the two expressions, but this is not the criteria for finding LCMs. Well, in order to find LCMs, we do not need to have common factors, but what we need is all the factors, okay, highest power of the included factors. So the LCM is x squared times x plus 1 times x plus 2. Here I have solved a creative question based on this lecture. Based on this lecture, I mean by factorization, by finding LCM and finding HCF. Okay, so let us see this example. The first question is determine the square of 3a plus 2b minus c, and the second question is determine the HCF of the first two expressions, and the third question is determine the LCM of the three expressions. Okay, so let us solve the first one. Here the first one is 3a plus 2b minus c whole squared equals 3a plus 2b minus c whole squared, and it fits into the identity of a minus b whole squared, and you know a minus b whole squared is a squared minus 2ab plus b squared. So as we have applied here 3a plus 2b, we can treat it as a, so 3a plus 2b whole squared minus 2 times 3a plus 2b times c plus c squared. And now the first term 3a plus 2b whole squared can be further reduced as a plus b whole squared as follows. So finally we get 9a square plus 12ab plus 4b square minus 6ac minus 4bc plus c squared. So let us solve the second question of finding the HCF of the first two expressions. The first expression is x squared minus 3x minus 10. As you can see that the second term can be written as minus 5 plus 2x plus, and the third term minus 5 times 2, as it fits into the identity of x plus a, x plus b, so we can write it as follows: x minus 5, x plus 2. Let us see the second expression. As you can see, x is a common factor, so we have taken it out, x squared plus 6x plus 8. Now 6 can be written as 4 plus 2, and 8 can be written as 4 times 2. That means it also fits into the identity of x plus a, x plus b as follows. So the second expression is x times x plus 4, x plus 2. Now from the first and second expression we can see that x plus 2 is the only common factor here, so the HCF is x plus 2. Now let us solve question number C. Now from B we get the first expression is x minus 5, x plus 2, and the second expression is x times x plus 4 times x plus 2. Okay, let us go for the third expression, and it is x to the power 4 minus 5x cubed minus 14x squared. As x squared is a common term, we have taken out x squared minus 5x minus 14. Now you can see that minus 5 can be written as minus 7 plus 2, and minus 14 can be written as minus 7 times 2. So you can see this also fits into the identity of x plus a times x plus b. So the final result is x squared times x minus 7 and x plus 2. So finally from these three expressions, the first expression, second expression and third expression, so we can see the power of x is 2, the highest, and x plus 2 is a common factor, so we need to take it, and we need to take x minus 5, as x minus 5 is not common factor, but we are finding LCMs, so we need to take all the factors, the highest power of all the factors. So the LCM of the expression is x squared times x plus 2, x plus 4, x minus 5, x minus 7, because we need to take all the factors while we are finding LCMs. Okay, keep this in mind. Now I have prepared a homework for you, and I suggest you to solve example 38 before solving this homework. Well, if you find this lecture complicated, you should let me know by your comments in the link below. Thanks for watching.